Welcome. Today we'll learn how to decompose a complex function into nested functions. Specifically, we'll break down the function f of x equals the cube root of quantity square root of x minus 1 into the form f of g of h of x. To decompose this function, we need to identify three separate operations that, when combined, give us our original function. Let's think about what happens to x as it goes through this function step by step. Let's identify the innermost operation first. Looking at our function, the first thing that happens to x is that we take its square root. So h of x will be the square root of x. Next, we subtract 1 from that result. This will be our g of x, which takes x and subtracts 1. Finally, we take the cube root of the entire quantity. This will be our f of x, which takes x to the 1/3 power. Now let's see how these functions nest together. Starting with x, we first apply h of x to get the square root of x. Then we apply g to that result, giving us g of h of x, which is square root of x minus 1. Finally, we apply f to get our original function. Therefore, our function can be written as f of g of h of x, where h of x equals square root of x, g of x equals x minus 1, and f of x equals x to the 1/3 power. Let's verify this with an example. Let's say x equals 16. First, h of 16 equals the square root of 16, which is 4. Then g of 4 equals 4 minus 1, which is 3. Finally, f of 3 equals the cube root of 3. This is exactly what we get if we plug 16 directly into our original function, the cube root of quantity square root of 16 minus 1. In conclusion, we've successfully decomposed our original function into three nested functions. Remember, when breaking down complex functions, work from the inside out, identifying each operation that's performed on the input. This technique is valuable for understanding function composition and can help solve more complex problems in calculus.